Hello everyone, and welcome to the session number 10, which is about in business research methods, which is going to be about sampling methods. We have talked last time about the research process and how we can collect data, from where we can get the data, and what is the setting, and what is the process of research. And one of them is how you can also take care and be careful about the unit of analysis, and how and from where we can get the data, and from where we can collect the data. So today we are going to talk about the sampling methods and how we can take sample to represent the whole population of the research. So the intended learning outcomes is going to be that after studying this chapter or this session, the student should be able to explain reasons for taking the sample rather than a complete census. So it's difficult to get the complete census and population, so we can take a representative sample. And also the student should be able to describe the process of identifying target population and selecting a sample frame. And again, we need the students also to be able to compare between probability and non-probability sampling, the two types of sampling, and also summarize the advantages and disadvantages of various types of probability sampling. Also, the students should be able to discuss how to choose an appropriate sample design. All these are going to be the intended learning outcomes of the ILOs of this session. Accordingly, the contents for this session is going to include basic concepts in samples and sampling, the stages in the selection of sample, determining sample size, the probability sampling methods, and non-probability sampling methods, which are the main methods of sampling. So what is sampling? To understand the sampling, we need to understand what is the sample plan, because to understand the sample plan, which is will include the population and then the sample, is very important. So in most of the research, in a lot of researches, if you are going to go for a census or take all the respondents or all the employees or people to answer your questions or questionnaire, for example, or give you data, you are going to face a lot of problems, because some of the population is going to be big, and the population is whoever is included in your scope and in your setting of your research. So the sample plan is the process followed to select units from population to be used in the sample. So the population sometimes is very big. You cannot cover it. You cannot collect data from all of it. So you need to take a sample. So the sampling plan can make this process easy. There are accordingly some concepts which is very important. As I said, the population is the first one. What is population? It is the entire group under study as defined by research objectives. So whoever can answer your questions is going to be the population, a part of the population. So sometimes called the universe. So it's the researcher universe. So researchers define population in specific terms, such as a head or heads of households, individual person types, families, types of retail outlets. So whatever people are or must be included in your research. So the population, geographic location, and time of study are also considered for that. The census is investigation of all individual elements that make up a population. So mostly you cannot take a census unless it is a small number, in number. So if the number is big, you cannot take the data from everybody in the setting under investigation or under research. So the sample accordingly is going to be a subset of the population that should represent the entire group. So the representation of the group is very, very important, because sometimes the population is heterogeneous, not homogeneous. So in this case, you need to divide into groups and take from every group, so you can make sure that the representation of this population is there. Because for every research you need to generalize the findings. You cannot generalize the findings for all the people, the targeted or the target people, unless you have drawn a representative sample. So there are some practical considerations, such as cost and population size, for why we take a sample. So some of the people will say, why don't we go for the census? Why don't we to collect data from the whole population? So there are a lot of problems will happen. The first one is the cost and the population size is going to be problematic, will take time. Inability of researchers to analyze large quantity of data potentially generated by a census. So this is also another problem. So a large quantity of data is hectic to be analyzed by the researcher. Sample can produce sound results in if proper rules are followed to or for the draw. So if I draw the sample in a proper way, so the results can be generalized, and it is just going to be just like the population data. So in most cases, census is unnecessary, as we said. To draw a sample, we have different stages we need to go through. The first one is define the target population. This is the first thing we have to do. So what is the population first, and then we will think about the sample. So the characteristic of the population is very important to be explained by the researcher at the beginning of the data collection process. Determine the sample size after you define the target population. So what is the sample size? And there are some statistical equation for that. There is a table, sampling table developed by Krigi and Morgan in 1970. This is can show how many population, and for that population what is the size of the sample taken. The third thing is determine the probability or non-probability sampling method, which is to be chosen, or that will be chosen. So either you go for probability or for non-probability. Mostly for quantitative research, we go for quantitative research. We go for probability, and non-probability sampling we go for qualitative. Then plan procedures for selecting sampling units. So what is the procedure to select the sampling units? And then select actual sampling units. So draw the sample, then conduct the field study after identifying your sample units and collect the data. According to Roscoe, he came up in 1975 with some rules for determining the sample size. So the first rule is sample sizes larger than 30 and smaller than 500 are appropriate for most research. Minimum sample size of 30 for each subcategory is usually necessary. In multivariate research, the sample size should be several times as large as the number of variables in this study. For simple experimental research, successful research is possible with samples as small as 10 to 20. This is very important also. And this is what we call the sampling table I have just explained by Krigi and Morgan. Krigi and Morgan 1979. So they determined according to some statistical equations the size of the sample for every number of population. So the n is stand for the population, the sample size is stand for s. So starting with a population of 10, the sample is going to be 10. But when we go to a population of 2,800, the sample is going to be 338. And when we talk about 30,000 units as a population, is going to be drawn a sample of 379. So if the researcher is going to follow this table and rather the reference which is Krigi and Morgan, so it's going to be helpful and it's going to be good for him or her. The basic sampling classification, as we said, we have different types of sampling. The first type is what we call probability sampling, and this types of sampling is ones in which members of population have known chance probability of being selected. So this is very, very important to understand, because it differs from non-probability sampling, and one of them is for quantitative research data collection and the other is for qualitative. So as we said, for probability, the ones in which members of population have known chance. This is the first thing you have to know. So the chance is known, and the chance also is equal. So if I have for example 200 for example so the known is chance for everybody, and it is going to be equal. So if I have, for example, 20 people or 20 employees, for example, and I will write their names and put in hats and ask somebody to take or to choose randomly and blindly. So it's going to be the chance is going to be known, and the chance is going to be equal for all of them. But when I go to the non-probability sampling, you can find that instances in which the chance, which is the probability of selecting members from the population, are unknown. So it might depends on the researcher, let's say guess or any criteria that can be chosen by the researcher. So here the chance is equal and known. Here the chance is not known, and it might not be equal for everybody. So for probability sampling, we have got a lot of techniques. The first one is what we call simple random sampling. It is one of the techniques of probability sampling. The probability of being selected is known and equal for all the members of the population. And the advantages of this type of method in probability sampling is that it is known and the chance is known and equal for selection. So a known and equal chance for selection. Everybody is going to wait for his name to be selected. Easy method when there is an electronic database, and simplest, fastest, and cheapest. These are the advantages. But we need to understand that this type of sampling needs the population to be homogeneous, and also it can work with small population. Otherwise it's going to be problematic. The disadvantage is complete accounting of the population needed. That's why we say in this type of probability sampling we need the population to be small, because we are going to do a complete accounting of population and that's going to be very important. So if this is the population, the random choice is going to be from different rows. So here 2, here 1, here 2. So it is unknown chance. So all these people, all these people are going to expect themselves to be here. You can find here are 5. Every member of population has an equal chance for being selected. That's why this one is not happy, because he is not selected. Okay. Probability sampling method also have another technique, which is systematic sampling. The systematic sampling is just very similar to the random sampling, but here we go through the draw of the sample systematically. So way to select probability based sample from directory or a list. So we will have a list at the beginning. This list must be organized according to certain criteria. For example, a list organized from A to Z, for example. Okay. To Z here. Okay, so A to Z. So the first thing to do is we will calculate what we call the sampling intervals. The sampling interval is dividing the sample size divided the population by the sample size. So if the population is going to be, for example, 2000, and the sample size according to Krigi and Morgan, for example, let's say is going to be 200, for example. So I will divide it 2000 by 200 is going to be 2000 divided by 200 might come up with 10. So the SI is going to be 10. So I will choose number 1, the first choice. The second choice must be 10. The third choice must be 20, 30, until I get to the last choice is going. I will come up with 200 units. So the population list size divided by the predetermined sample size, I will come with the SI. So how to draw this sample? But by the way, I have just explained. So if the number of population is going to be 100, and I want 20 as a sample, so 100 divided by 20, I will come up with 5, which is the interval. So the choice is 1, then 4 or 5. Then so I might have chance to move from 1 to 4. So I might start with 2 or with 3 or with 4, with 1, but not with 5. So if with 1, the second choice is going to be 6. If I have started with 4, the second choice is going to be 9. If I will start with for example 2, the second choice is going to be 7. So until I get the whole sample. The systematic sampling advantages is again known and equal chances of any of the let's say clusters being selected, or the sampling interval being selected, or the units being selected. Efficiency, because do not need a designate or assign numbers to every population member, just those early on the list. So in the simple random sampling, we take the names or numbering the names and then put in a box or a hat, and then do the drawing of the sample. This type of sampling also, which is the systematic sampling, also is can go with the homogeneous population, and also the number which is small, just like the simple random sampling. So it is less expensive, faster than simple random sampling, because it's going to depend on lists. The disadvantages of this type of sampling is that it needs to be careful on how list is ordered to avoid bias. So there must be a criteria to organize the list so the bias is not going to be there. So this not like the simple random sampling. Here the choice is systematic. So this is the intervals 1, 2, 3, 4, and then we choose here 1, then 1, 2, 3, 4, and then we choose here. So the interval is the same. So for each. The third technique of sampling is what we call cluster. This type of sampling is very, very good, and it can solve the big number of populations, because sometimes if I am doing research about customer satisfaction, in telecommunication companies. So in Yemen, for example, so the population here is going to be millions, might be 9 millions. So it's a big population. So we cannot use the simple random sampling because we need a count of every single unit in the population, and this is a big number. We cannot also use the systematic. We need plenty of papers and plenty of lists, and this is very, very difficult. So we can use the cluster sampling by dividing the country or the population into districts or geographical clusters or places, and then I choose randomly one of them. So a method by which the population is divided into groups or clusters, and also divide the population into clusters along geographical boundaries or any other criteria. So the cluster can be villages, towns, districts, urban blocks, whatever, and then those clusters are many population and therefore are heterogeneous. Once clusters are established, the random draw is done to select one or more clusters to represent the population. So for the customer satisfaction telecommunication companies, we can divide, for example, Yemen into districts. So we'll have or provinces. We will have 21 provinces. So we'll choose one, and if we come up with, for example, randomly, we'll choose Sana'a, and then divide Sana'a into districts, and then divide the districts into blocks, and then choose one of the blocks, and it's going to be representative for the whole population. So like the area sampling. So the cluster sampling advantages is economic efficiency, because I am going to take a small place, and this small place is going to be representing the whole population. Faster and less expensive than SRS. Doesn't require a list of all members of the universe. So the disadvantages of this type of technique of sampling is cluster specification error. The more homogeneous the cluster chosen, the more imprecise the sample results. So for the customer satisfaction telecommunication, I might come up with a district in Sana'a. And when I talk about the customer satisfaction, there are some districts in Yemen in which there are a lot of problems, much more problematic than Sana'a, like places like Al-Mahra province, or Suqatra, or Al-Mahwit, different districts which is far away, and it is unfair to compare the services of the telecommunication companies in those places and in the main cities in Yemen. So in this case, I can divide all the population into two groups. The first group is going to be the districts which is getting high service or good service, and some provinces with weak services, and then I choose two districts, one from the highest one and other one from the lowest one. So the cluster sampling can be also, as I said, area method. Draw in the area sample, divide geographical area into sectors, sub areas, and then give them names, numbers, determine how many sector are to be sampled, and then typically a judgment call, randomly select these sub areas. So I can have this area divided into districts, so I might choose this district as one of my as I said, one of my sample, or as my sample. So cluster sampling area method, a two-step area cluster sample. So the cluster sampling is a two steps area. Cluster sampling several clusters is preferable to one step, and then selecting only one cluster sample unless the clusters are homogeneous. So if it's heterogeneous, I might come up with two clusters. If homogeneous, one cluster is enough. The fourth technique of probability sampling is what we call the stratified sampling. This is one of the best techniques of drawing sample. This technique, the population is separated into homogeneous groups or segments, strata, called strata, and the sample is taken from each. So the sample stratum size determination, proportional method, which is going to be divided into according to the proportion or the percentage. So stratum share of total sample is stratum share of total population, and this proportional, which is going to be variance among strata, affect sample size for each stratum. The stratified sampling is like what we will explain in this example. So the people or units are aggregated into subgroups called strata. A certain number of units are sampled from each stratum. So if the company is having 4 departments, so and in the whole company we have 1,000 employees, so I will take the sample from every department, whether proportional, in which I will calculate the percentage here and draw the sample according to the percentage representing the population here, or non-proportional. That means I can divide 1,000 by 4, so I can take 250 for each department. The probability sampling also stratified sample or sampling advantage, as it is more accurate and representative, because you need to draw from every single heterogeneous group. The disadvantages, or the disadvantage is one disadvantage, which is more complex sampling plan requiring different sample size for each stratum. The second method of sampling is the non-probability sampling, and I said this method is going to be for qualitative research, because the chance is not known and the chance is not equal for the population to be chosen here. So the first one is convenience sampling, a sample drawn by the researcher at the convenience of the researcher or easy access. So the people that the researcher can reach them can be included. But there must be some problems here in this method, like error occurs in the form of members of population who are infrequent of that location or who are not typically in the population. So sometimes somebody will come if the researcher is going to stand at the gate of the company and choose whoever is appearing. The non-probability sampling also method is having also another technique, which is judgment sampling. So this is a sample which is dependent on an educated guess by the researcher, so that require a judgment or educated guess on the part of the researcher as to who should represent the population. So subjectivity is there, enters in here, and certain members of the population will have a smaller or no chance of selection compared to others. The third one is what we call the snowball samples, which is the referral sampling. So when the snowball is start moving, it starts very small, and when it moves, it's going to be bigger and bigger. So this is the sample which requires respondents to provide the names of additional respondents. So the researcher is going to choose the first respondent, and when he finishes the interview with him, for example, he will or she will ask him for to recommend another candidate. So the last one is what we call the quota sampling, a sample that set a specific number of certain types of individual to be interviewed, male or female. If we have, for example, 60% is male, 40 is female, so you need to divide them according to the quota and take from both the groups. This is everything about the population and sampling in research and in business research. I hope everything is clear to you, and I hope that throughout this session you have learned how to explain the reasons for taking a sample rather than a complete census, and a description of the process and of identifying the target population and selecting a sampling frame, and also comparing between probability and non-probability sample, and also summarizing the advantages and disadvantages of the various types of probability sampling, and at the end discussing how to choose the appropriate sample design. The assignments for this session is going to be, as usual, uploaded, attached and uploaded in the LMS. We have come to the end of the session, which was about sampling and the population and sampling. So we have discussed the basic concept of sampling and samples, and also we have discussed the stages in selection or in selecting sample, and also determining sample size. And also we have talked about different types of sampling, which is probability and non-probability. We talked about 4 types of sampling methods in probability sampling, and also another 4 types for non-probability. And we said probability sampling is going to be for quantitative type of research, and the non-probability is going to be for qualitative because of certain rules and criteria. So we come to the end of this session. I hope everybody has get all the knowledge needed for to draw a sample for their own research, and understood everything about the sampling. So thank you very much for listening. Thank you.